What if I told you Earth holds secrets even science can't fully crack? Imagine landscapes so bizarre, so defying of explanation, they make you question everything you thought you knew about our planet. We're talking about colossal structures that look like a giant bullseye painted on the desert, and beaches covered in cannonball-sized rocks that seemingly just grew there. These are the geographical anomalies. Get ready to dive into the world's most baffling geological formations. Prepare to. For most of human history, we thought we had the planet figured out. Mountains are folded, rivers carve valleys, volcanoes erupt. Simple, right? Well, forget everything you think you know about how mountains are made or rivers flow. Today, we're exploring places on Earth where geology went rogue, leaving behind monumental puzzles that stump even the smartest scientists. Geologists have dedicated their lives to understanding the precise, predictable mechanisms of our world. They have equations for erosion, timelines for plate tectonics, and a pretty solid understanding of how a rock forms. But then you show them a perfectly hexagonal stone column that stretches for miles, or a vast, circular formation visible only from space, and suddenly their textbooks don't quite cover it. Are you ready to confront formations that seem to break all the rules of nature? Close your eyes and picture towering structures that seem carved by giants, or immense patterns etched into the land by an unseen hand. These aren't fantasy, they're real places on Earth, and their origins are shrouded in mystery. We're about to dive deep into these anomalies. We'll look at the Richat structure, the giant eye of the Sahara, and weigh the theories. Was it an impact from space or just a very, very confused dome? We'll visit the giant's Causeway to see nature's impossible geometry and explore the beach where the mysterious more rocky boulders seemingly spawned. We'll explore the rigorous, sometimes outlandish theories that try to explain them. We're not just looking for rocks. We're looking for evidence that will rewrite the very rules of the Earth we live on. Join us as we journey to uncover the mind-bending tales behind our planet's most unexplained geological wonders. Now that we've established that Earth plays by its own rules, it's time to meet the three heavyweights, the titans of geological mystery. These are not subtle anomalies. They are monumental structures that slap geologists across the face with a simple question. We start with a feature so massive, it's literally easier to see from space than it is from the ground. Our first stop is the Mauritanian desert, home to the breathtaking Richat structure, better known as the Eye of the Sahara. Imagine a series of perfectly concentric circles 25 miles wide like a giant geological bullseye. It's so huge and so distinct that early astronauts used it as a landmark. When photos first came back, the scientific community had one initial knee-jerk reaction: impact crater. It has the scale and the striking symmetry of a massive meteor strike. But here's the problem. When geologists studied the rocks, they found no evidence of shocked quartz or the kind of melted rock common in impact zones. No smoking gun. So the current, widely accepted theory is that the Richat structure is a highly symmetrical, deeply eroded geological dome. Essentially, a massive bubble of rock pushed up from below, and over millions of years, the layers eroded at different rates, leaving the distinctive ring pattern. Think of slicing a giant onion in half, then peeling back the layers one by one. But here's the punchline. Geologists will tell you this happens all the time, but nowhere else on Earth does it happen with this level of near-perfect circularity and scale. It begs the question, what made this dome so incredibly symmetrical? Was it a freak coincidence, or is there an uncatalogued mechanism at play deep within the crust that only expressed itself perfectly here? Next, we travel all the way to the rugged coastline of Northern Ireland, to the Giant's Causeway. Forget perfect circles. Here, we find perfect geometry. Imagine 40,000 interlocking columns, mostly six-sided, packed so tightly they look like a man-made tiled floor built for giants. Geology tells us these are the result of intense volcanic activity 60 million years ago. As molten basalt lava cooled rapidly and uniformly, it contracted and fractured, creating these textbook hexagonal pillars. It's a stunning display of physics. But let's be honest, the scientific explanation, while accurate, doesn't quite capture the sheer magic of the place. How did nature achieve such uniformity on this scale? The symmetry is so precise it looks laser-cut. And this is why the ancient explanations are so much more satisfying. Local legend says the columns were built by the Irish giant Finn McCool, who constructed a causeway across the sea to fight his rival in Scotland. When you stand on those perfect hexagons, the myth starts to feel a lot more plausible than the idea of just uniform cooling. This site proves that sometimes nature has a flair for the dramatically unnatural. Finally, let's hop to the sands of New Zealand's Cocoa Beach, home to the unsettlingly perfect Moraki boulders. Picture gigantic gray marbles, up to 7 feet wide, scattered along the shoreline. They look exactly like colossal cannonballs that rolled off a ship 60 million years ago. The consensus is that these are concretions, which is a fancy word for cemented masses. They formed millions of years ago, deep in the mudstone, through a process similar to how a pearl forms. Calcium carbonate slowly crystallized around a central core, often a fossil or a piece of shell, growing outwards layer by layer. The puzzle here isn't the process itself, but the uncanny perfection of the sphere. Geologists can explain a boulder, they can explain crystallization, but they struggle to explain the sheer volume of these perfectly spherical stones concentrated in one spot. It's a beautiful, baffling testament to the power of tiny chemical reactions carried out with patience over an almost incomprehensible timescale. The planet, it seems, has a hidden factory dedicated to making the world's most perfect marbles. These 3 sites, the eye, the causeway, and the boulders, prove that even the most basic laws of geology have exceptions, leading us to our next question. If the surface holds these mysteries, what else is hidden below? We've seen what happens when nature follows its rules in the most bizarre way possible. Now, let's explore the places where the rules don't just bend, they snap. These next locations force us to look beyond the obvious geological mechanisms, sometimes hinting at unknown forces, extreme conditions, or even civilizations we know nothing about. Prepare to put your tinfoil hats on. Just for a moment. Our journey takes us high into the Peruvian Andes, to the ancient Incan fortress of Sacsayhuaman. This isn't strictly a natural formation, but the engineering challenge it presents is a geological puzzle in itself. Look at these walls. They are built from massive limestone blocks, some weighing over 120 tons. They are fitted together with such incredible precision, polygonal stonework, that you cannot slide a single sheet of paper between the stones, even after centuries of earthquakes and erosion. There is zero mortar. The official explanation is that the Inca somehow managed to carve, transport, and fit these irregular blocks using only copper tools, levers, and sheer manpower. It's an accepted theory, but for many engineers and archaeologists, it simply doesn't add up. The angles are too complex, the fit is too perfect. This lack of satisfying explanation opens the door to the unconventional. Could this have been built by a precursor civilization with advanced, forgotten technology? Did the builders somehow soften the stone before interlocking it, allowing it to fuse? When the scientific answers strain credulity, we are forced to confront the possibility that the Earth harbors secrets of lost knowledge as much as lost geological processes. Let's pivot from ancient stonemasons to geological magic, descending deep beneath the Sierra de Nica mountain range in Mexico. This is the Cave of the Crystals in the Nica mine, arguably one of the most hostile and beautiful places on Earth. It's a giant underground geode. Within this humid 120-degree oven lie the world's largest known crystals. Selenite blades up to 36 feet long. The conditions are brutal, nearly 100% humidity and extreme heat. How did they form? The scientific answer is fascinating. A magma chamber below the cave kept the water temperature stable for at least 500,000 years. This Goldilocks zone allowed the calcium sulfate-rich solution to slowly precipitate into these colossal crystals. But here's the unconventional part. The sheer size and the speed of the growth, geologically speaking, suggests an unparalleled sustained energy and chemical flow. It implies a stability in the Earth's plumbing that we rarely see. It pushes the boundaries of what is possible. making us wonder if other unknown, super-stable thermal systems are creating even more extreme formations deeper in the crust that we simply haven't found yet. Nika is a vivid, shining reminder that our planet's slow, hot plumbing can create marvels far beyond human scale. For our final unconventional stop, we travel to the ultimate frontier, the deep ocean floor. We're talking about hydrothermal vents and the black smokers. These aren't just holes in the ground, they are chimneys of pure mineral creation. Imagine scalding hot, superpressurized water, often over 700 degrees Fahrenheit, gushing out of the seafloor. This water is loaded with dissolved metals and chemicals pulled from the Earth's crust. When this superheated water hits the near-freezing seawater, the minerals instantly precipitate, forming towering temporary chimneys composed primarily of sulfides. That's why they're called smokers. It's not smoke, it's a chemical reaction. Why is this so unconventional? Firstly, they prove that geological formation can be rapid and dynamic. These chimneys can grow and collapse quickly. Secondly, they support entire ecosystems based not on sunlight, but on chemosynthesis. This is geology meeting biology in the most extreme way. The unconventional question here is profound. If the Earth's crust can be this volcanically and chemically active right now, creating complex structures and supporting unique life in the deep abyss, what other, non-uniform chemical anomalies are happening globally? Are there forms of crystallization, mineral growth, or even slow-moving lava flows that completely bypass our current models? The black smoker is a window into a constantly shape-shifting, chemical and biological environment that defies static geological definition. It reminds us that our planet is less of a solid ball and more of a colossal living chemical reactor. We've spent the past few minutes staring at geological impossibilities. But here's the key takeaway. For every baffling sight, there's an entire global community of scientists who treat these anomalies not as fantasy, but as the ultimate, multi-million-year-old cold case. This is the scientific scramble, where the world's greatest minds constantly refine, retest, and sometimes completely tear up old theories to understand the Earth's most stubborn puzzles. How do you even begin to study a 25-mile-wide circle in the desert? You can't just walk it with a measuring tape. You need tools that see the world in ways our eyes can't. Enter LiDAR, light detection and ranging. This technology shoots billions of laser pulses down to the Earth's surface. Think of it as digitally shaving off the atmosphere and the vegetation to reveal the true raw topography of the land. With LiDAR, geologists can map the subtle elevation changes within the Richat structure down to the millimeter, helping them precisely measure the fault lines and the dipping of the rock layers. It's the difference between looking at a faded old map and getting a crystal-clear, high-definition 3D scan. Then we have geological modeling. Scientists plug huge amounts of complex data, seismic readings, pressure figures, rock composition, into powerful supercomputers. They run simulations, essentially creating digital Earths, trying to replicate formations like the giant's Causeway or the perfect spherical Morocco boulders under specific, controlled conditions. They play God with physics, attempting to force the laws of nature to create the anomaly on a screen. If they can make the perfect hexagon appear in a simulation, they know they're closer to the answer in the field. Science isn't about finding an answer, it's about finding the best answer. And these puzzles ensure the debate stays fiercely alive. The constant need for re-evaluation is key. Sometimes, the oldest, most established theories get completely overturned. Think about the history of geology. The idea of continental drift was ridiculed for years, yet plate tectonics is now the cornerstone of our understanding. These anomalies are the very things that push us toward the next great revolution. Advanced techniques allow us to look at old evidence with new eyes. We can re-evaluate the crystallization rate of the Morocco boulders using new isotopic dating, completely shifting the accepted timeline. We share mineral composition data from a deep-sea vent, and suddenly, a geologist studying an ancient volcano realizes that tiny chemical factor might explain why the lava flowed so uniformly 60 million years ago. It's a global jigsaw puzzle where every field of science contributes a piece. These formations force a humility on the scientific community. They remind us that the planet doesn't care about our neat, tidy equations. Despite all our technology, the Earth is still the ultimate challenging professor. We've analyzed symmetry in the Sahara, geometry in Northern Ireland, and crystallized perfection in a Mexican cave. But before we wrap up, we have one final mind-blower, an anomaly that puzzled scientists for nearly a century because it broke the most basic rule of physics. Heavy things don't move themselves. It proves that sometimes the strangest truth is simpler, yet far more elegant than any complex theory. Our final destination is the desolate, flat expanse of the racetrack playa in Death Valley, California. The playa is known for its sailing stones, hundreds of rocks, some weighing hundreds of pounds, that move across the dry lake bed, leaving long, distinct trails etched into the mud. For decades, the movement was a total paradox. Theories ranged from high-speed wind gusts to magnetic fields to even microbial mats facilitating the slide. But the ultimate barrier to understanding was simple. No one had ever seen them move. Geologists would track them, leave the site, and return months later to find the rocks had repositioned themselves, sometimes hundreds of feet away. It was a true mystery of self-propelled geology. The mystery was finally solved in 2014, and the answer is pure genius in its simplicity. It requires a perfect, almost impossible confluence of three conditions. First, the playa must flood shallowly. Second, the shallow water must freeze overnight, forming thin, transparent sheets of ice. And third, the sun must begin to melt the ice, creating floating panels. When a gentle breeze, not a gale, pushes these floating ice panels, they drag the submerged stones along, leaving those telltale trails in the soft mud beneath. But here's why it's still a mind-blower. This phenomenon shows us that a force as subtle as a light breeze acting on a floating sheet of ice under a specific thermal window can overcome the friction of solid rock. If tiny, local, perfectly timed forces can produce such dramatic results, what are the truly massive planetary scale forces doing that we can't observe? That is the persistent question that haunts modern geophysics. We've focused on the surface anomalies, but what is happening deep within the core and mantle? We rely on seismic data to map the deep Earth, and yet we still find areas, massive blobs of rock at the core mantle boundary, that simply don't make sense. Are these the ancient nurseries for the domes and volcanoes we see today, governed by unknown gravitational or thermal factors? We must also consider the extraterrestrial influence. While we ruled out a simple impact crater for the Richat structure, how do subtle cosmic factors like the specific gravitational pull of the moon and sun, or tiny, continuous deposits of cosmic dust, affect the chemistry and stress of rock structures over billions of years? We know Earth is an open system, constantly being influenced by its celestial neighbors. The most profound realization is this: the anomalies we study, the perfect crystal caves, the sailing stones, the geometric columns, are not flaws in Earth's design. They are evidence that the planet is exponentially more complex than our models suggest. They are the fingerprints of powerful, beautiful, and sometimes utterly invisible forces. Now, close your eyes one last time. Picture towering structures that seem carved by giants, or immense patterns etched into the land by an unseen hand. Feel the deep-sea heat of the smokers, hear the silent slide of a sailing stone. These aren't fantasy, they're real places on Earth, and their origins, even when explained, are shrouded in the mystery of immense time and perfect chance. The planet continues to be the ultimate storyteller. We started this journey asking the impossible question: what if everything we knew about Earth was wrong? We've seen the monumental puzzles that challenge that knowledge, the perplexing Richat structure and its mysterious symmetry, the perfectly geometric columns of the giant's Causeway, the deep, blazing chemistry that creates the massive crystals of the Nika cave, and finally the eerie, slow-motion ballet of the sailing stones in Death Valley. These anomalies are proof that our planet is less of a rigid machine and more of a complex, evolving, and highly unpredictable laboratory. They are a constant reminder to geologists and to all of us that the most beautiful discoveries often lie just outside the boundaries of established science. Now, it's your turn to decipher the evidence. We want to know, which geological puzzle truly blows your mind? Are you convinced that the Richat structure is just an eroded dome, or do you side with the more outlandish theories? Does the precision of the Sacsayhuaman walls suggest a forgotten technology, or just incredible human ingenuity? Leave your favorite geological puzzle and the most compelling theory that explains it in the comments below. Let's keep this scientific scramble going. And if you enjoyed confronting these planetary mysteries, be sure to hit that like button and subscribe. We've got plenty more secrets hidden beneath the crust to explore in future videos. Your support helps us fund the next expedition into the unknown. Because despite all our advanced tools and centuries of study, the truth remains. We know more about the far side of the moon than we know about certain parts of our own planet. The anomalies are not errors, they are invitations. The geological revolution is ongoing. Thank you for joining us on this journey into the truly unexplained. We'll see you in the next anomaly file.